All right, everybody, welcome to our lesson today on discriminants. Right? So the whole point of discriminants is to figure out just at a glance how many solutions a quadratic equation would have. So sometimes a quadratic equation can have two solutions, they can have only one solution, or they have zero solutions. And by finding the discriminants, we are able to figure out right away how many solutions that this function would have, or this expression. And by finding out the discriminants, we'll figure out right away how many solutions this question will have. Right? So starting off with the quadratic equation, this is what we'll be looking at today mostly, the b squared minus 4ac part. And now looking at this here, if b squared minus 4ac, right, if this part, if that's bigger than 0, we will have two solutions. If this part right here equals to 0, we only have one solution. And if this part is smaller than 0, then we have zero solutions. Right? And we can quickly check to see if it's why that is. So if we look here, right, we have just negative b plus or minus a random number here. If this number here is positive and above 0, say for example like 5, right? If this number here is, let's say, 5, then no matter what the b and the a is, we will always get two solutions, right? It will be b plus root 5 over 2a, or b minus root 5 over 2a. Right? If it's positive, we get two solutions. And now, in our next scenario, right, we have 0. We get 0 right here, which means that negative b plus or minus 0, well, that'll just be 0, right? So then we'll only have one solution, which is just negative b over 2a. And now, in the last case, right, so that's the only solution. In the last case here, we have a negative number, negative 5, for example. Now, that's illegal. You cannot square root a negative number unless we're working with imaginary numbers. But in this case, we are not. So this is why discriminants are very useful. Just by looking at what's inside that root over there. If it's positive, two solutions. If it's 0, one solution. If it's negative, 0 solutions. Right? So let's do some examples. You might be wondering, what do those alphabets mean? Why is there a B, a A, and a C? Right, so remember our general form, right? So quadratic equations are always going to be shaped like this. We have ax squared plus bx plus c. And those alphabets here, right? The a, the b, and the c, those are coefficients, right? Or those are just the numbers in front of a term. Or I guess not in c's case, but in the case of the a and the b, those are just a number that's right in front of the x squared and the x. So let's check it out. In our first example, we'll first determine what a, b, and c is. The a is just negative 2, right? Again, this is just a number in front of the x squared. B is a number in front of the x, which is 3. C is the number by itself, or the constant, which is 8. And from here, remember, the discriminant is b squared minus 4ac. So I'll write it down here. B squared minus 4ac. All right? B squared, we know that's 3. So 3 squared minus 4 times a, which is negative 2, times 8. Okay? So minus 4ac. And from that, we get 9 plus, so 4 times 2 is 8. 8 times 8 is 64. But because you have two negatives, we have a plus. That's 64. 9 plus 64, 73. We know 73 is bigger than 0, which means that this question right here, right, this question right here has two solutions. Okay, so we can box the discriminant, and we'll say two solutions. Moving on to this question here, we can quickly rearrange this. All right, we'll bring the 9 over. Okay, so we add 9 to both sides. From there, same thing, b squared minus 4ac. So in this case, the b is negative 5. All right, remember, we have to, whoops, that's a ruler. always have to include this negative sign right here. Right? So b is negative 5, so negative 5 squared minus 4 times a, which is 3, times 9, which is c. All right, this will fetch us, let's see, 25 minus 12 times 9. So 4 times 3 times 9, so 12 times 9, which is 9, 12, 8, 108. That's a very negative number, as you can see right away, right? So that comes out to be, let's see, we get negative 83. Yes, negative 83. All right, negative 83 is smaller than 0. All right, so which means this has no solutions. Right, this quadratic equation right here is unsolvable. Okay, lastly, we got fractions here, but to be honest, it doesn't really affect much. Right, so again, b squared minus 4ac. So in this case, the b is negative 3 squared minus 4ac. So we have 4 times a, which is 1 over 4. Wow, look at that, conveniently cancels out. Times c, which is 9. This will get us negative 3 squared is 9, minus 4 times 1 over 4 is 1. 1 times 9 is 9, which is 9, because it's 0. Right, well, I guess 0 equals 0, but we already knew that. So from here, because a equals to 0, we know that this quadratic equation has exactly one solution. Right, so yeah, that's pretty much it. That's how we use discriminants. We just take the b squared minus 4ac, and we compare how big or how small is it compared to 0. And we can actually check with graphs. So those are just very, very rough graphs right here. Right, I didn't label any of the axes or anything, but this is just to get an idea. So as we can see, the general shapes are all the same, right? In this first graph here, our first question, we have 1, 2, right? We have 2 roots here. This graph touches the x-axis 2 times, so it has 2 roots or 2 solutions. Right? And once again, the discriminant is 73, right? So that's bigger than 0. Our next equation, we have no roots, right? So it does not touch the x-axis at any point. And because it doesn't touch the x-axis, it has 0 solutions. Okay, so again, from earlier, we know that this equals to a negative 83. And the last one, we have 1 root. Right, it touches the x-axis at exactly 1 spot, giving us 1 solution. And the b squared minus 4ac was 0, as we found earlier. Right, so just a quick technicality. Technically, this last one right here, there are 2 solutions here, but they're just overlapped on a single spot. So even though there are quote-unquote 2 solutions, they're both the exact same solution. So we just treat it as 1 root or 1 solution. Yeah, just technicality's sake. Okay, with that being said, let's try some exercises. So pause the video here and try those questions out yourself. All we are doing here is to use discriminant. So once again, I'll write it out again. B squared minus 4ac. Using that to figure out how many solutions each question have. Right? We don't need to solve them yet. We just need to figure out how many solutions they have. Okay, so hopefully you took a crack at the questions. So the first question, right? So we have A, we have, the pen's too thick. So now for the first question, A is just 1, B, negative 7, C is 4. We just plug into the formula, so B squared is negative 7 squared minus 4 times A, which is 1, and C, which is also 4. This gets us 49 minus 16. Right, this seems very positive, and it is, which is 33. We know 33 is bigger than 0, so this question right here has 2 solutions. Right, you're more than welcome to check on a graphing calculator if you're unsure. Right here, A is 1, B negative 2, C positive 1. Alright, so B squared is negative 2 squared minus 4 times A, which is 1, times C, which is also 1. 4 times 2, 1 times 1, we just get 4 minus 4, getting us 0. Which means there is 1 solution. We can quickly check this one too, right? n squared minus 2n plus 1. This is just n minus 1 squared equals to 0. Right? So we know n is just 1. Right? So this is the only solution right here. And lastly, a is 7, b is 3, c is 2. So b squared, we get 3 squared minus 4 times 7 times 2. Looking very negative so far. So 3 squared is 9. Minus 20, 4 times 7 is 28. 28 times 2 is 56. This gets us negative 47, which is smaller than 0. Which means that this question, 0 solutions. Right? So on our graph, this will not touch the x-axis. Alright, so yeah, that's pretty much it. Discriminants, all we need to do is use the b squared minus 4ac. We just plug it in and figure out how many roots there are. Right? If it's bigger than 0, a will be 2 roots or 2 solutions, equals to 0, 1 solution. Smaller than 0 or negative number is 0 solutions. And that's pretty much it. Alright, so the next class we'll actually learn about how to use this quadratic equation. But for now, all we're doing is just figure out, just at a glance, can I even solve this question in the first place? Alright, so with that being said, keep practicing and stay hydrated.